And we are live. Welcome to Community Office Hours. I'm Rosemary Wang. We have Rob on here. We also have Jason here. And this is our KubeCon North America special. If you have any questions or comments, we'd love for you to interact with us in the chat. However, as you do, please keep in mind our code of conduct in this virtual space. In general, be welcoming, inclusive, friendly, and patient. Be considerate, be respectful, be professional. You can review our code of conduct at hashicorp.com/community-guidelines. With that, let's get started. This week, you're going to have a whole slew of experts coming to talk about HashiCorp tools plus Kubernetes. Today is going to be Vault, and then we have a couple of console ones, Nomad ones, Terraform ones. You'll see them throughout the week. Check our community office hours page if you're interested in learning more. And so today, what we're going to do is start with Jason, who's going to talk a little bit about what's new with Vault plus Kubernetes. I think there are a couple of neat features that you mentioned to me, and I'm interested in learning more.
Yeah, thanks for having me, Rosemary. So Vault 1.6 just released, and there is a new Raft integration that allows you to auto-join nodes in the Vault cluster to the Raft cluster. So before, you would have to manually join each node. When you're bootstrapping a Vault cluster, you'd have to manually join the node to the Raft cluster. And once it's joined, then things are pretty good and work well. But that initial bootstrapping of the cluster was a pain point. So in 1.6, there's now a Raft auto join feature. And how this is specific to Kubernetes is one of the providers that you can use for auto join. And it does that by using labels on the pods. So it can do a discovery of pods in this namespace with this specific label. And if you use our Vault Helm project, we automatically have labels there that you can discover and use for this auto join. And all you do is put in the configuration file for Vault, this auto join stanza with the labels that you want to search, the namespace that you want to search them in. And then it will find all of the pods in Kubernetes that match that criteria and automatically join that. And that's really cool because if you pair this with like a KMS auto unseal, you can get auto join and auto unseal and be able to expand your cluster on demand and automatically just join and unseal the vault. And that's a really cool integration, specifically in like Kubernetes, where you have so much elasticity of, I want this many servers running. I want to increase, my Vault cluster so I can do more processing. That's a really cool integration, and it works really well with Kubernetes. We're going to be adding into Vault Helm this by default in the coming weeks. In the default Raft configuration file, we'll add that. So out of the box, you'll just get that, and you can just use it, which is really cool. And this is not an enterprise feature. It's in both open source and enterprise, which is really cool.
That's awesome. How close is this to, let's say, like the console auto join, for example?
It actually uses the same, I believe it's called Go Discover is the project that actually does all discovery. And it's, I said Kubernetes specifically because we're talking here at KubeCon, but there's tons of other platforms and providers that Go Discovery uses or can integrate with. So Amazon, Google Cloud, DigitalOcean, there are specific providers for all those. So it's very similar to the console, and I believe they use the same package under the hood, if I'm not mistaken.
That's really cool. So I guess my question, and something I was always curious about, is like how many people are doing sort of this manual unseal for Kubernetes versus auto unseal for Kubernetes?
Yeah, good question. So it depends really where you're running your Kubernetes cluster. If you're running Kubernetes in like a bare metal situation, KMS can be a little bit harder for you to have access to. But like in things like GKE and EKS, you get the KMS provider provided by like the cloud platform, which integrates really well with Vault. Now, Vault itself can be used as a KMS provider using the transit service. But you kind of have this chicken and egg issue where you need to unseal the transit server to use it to auto unseal your Vault cluster. So you get a little bit more infrastructure that you need to maintain. Plus, you need to manually unseal something at some point. So the cloud integration is a little bit nicer in that regard, and it works really well in like GKE and EKS. But if you're so that's basically where I've seen the divide is. I'm running in the cloud Kubernetes or I'm running on bare metal, and there's different implications there.
Nice. So Rob, are you excited for Raft auto join after hearing all this?
Absolutely, it's one of the things that as soon as integrated storage was announced, I went straight away and said, "Oh, so does it have the same kind of maturity in functionality as console?" And where it didn't, I'm really happy that it's been such a quick turnaround from integrated storage going live to us now having some of the console functionality built into it. And yeah, just to kind of hammer on to one of the points that Jason made, Go Discover is an open source library that is under the hood for a lot of our tools there. If anyone wants to use that, I believe a link is going to be posted in the chat. But yeah, it's definitely an awesome library and something I'm a big fan of.
Nice. I have still yet to look at that library. I feel like there are all these HashiCorp created libraries that do really interesting things. Go Getter is another one. Go Discover is another one. And I haven't dug into them as deeply. And I now need to go back to Go Discover and see what's it all about. So we did put it in the chat, and that's going, if you're curious, you can go ahead and take a look at it. Shifting off of Vault 1.6, we have a new product that we announced at HashiConf, and it's called Waypoint. And with Waypoint, its focus is to build, deploy, and release applications. I guess you can build, deploy, release applications on Kubernetes too. And so how does Waypoint and Vault work together? Why would you decide to use Vault with Waypoint to deploy to Kubernetes? That seems like a lot of extra complexity, right?
Yeah, definitely. And so I need just to be clear about Waypoint. Currently, the integrations between Waypoint and Vault are minimal, but there is more coming. And you'll see some in 0.2 Waypoint and on. There's going to be a lot more integration and better together stories with the HashiCorp products, which is going to be really cool. But when Waypoint launched, we were able to add simple integration with the Vault Agent Secret Injector, which is a HashiCorp project that allows you to inject Vault Agent containers into your into your application pods, so that you can consume Vault secrets. Basically, it uses a sidecar pattern and will deposit secrets into a shared memory volume between the containers. And to get Waypoint the ability to use that, we just needed to add a few just little like the ability to write annotations to the pod and then specify a service account, because the service account in the Kubernetes world and the Vault world is what your pod uses to authenticate to Vault and get a token so that it can access secrets. So using those two, annotations and a service account, we can now consume Vault secrets on a Waypoint deployed application, which is really cool. And I can show a demo if you'd like.
Yes, we'd love demo.
Okay. Let's
see. And I will ask the demo entities to grant us a working demo.
So, yeah, we'll see. I don't mind debugging live though. I think it's always fun to kind of see somebody go under the hood, but I hope I don't have to.
Yeah. If side note for those in chat, if you would like us to increase the font size some more, just let us know. From my view here, it looks, a fairly good view, but if you would like us to bump it up, in terms of the font size, just let us know in the chat. Thanks.
Yeah, I bump it up for myself.
It's a good size. I mean, I appreciate it. I can see it, and I'm on the tiny viewer screen. So
I didn't want to bore everybody with the setup details. There's a bit of infrastructure involved here, but in this, I'm running this on GKE. You can see down below I have a series of pods running. And I shared a link to this example repo if you're interested in recreating this in your own environment. But what I'm going to be doing is deploying an application using Waypoint into a GKE cluster and consuming Vault secrets in that application. So the secrets that the app is going to be consuming are Postgres database credentials. So it's going to connect to a Postgres database running in GKE. And we can see that down here. This Postgres database is running. It's already been bootstrapped with some DDL. There's some data in a table. It's basically going to read that and display it in a web app. And then it's also going to use the Vault Transit service, which is Vault's encryption as a service. So it'll take some data and encrypt it and decrypt it just to kind of show the functionality. But all that requires is a Vault token and the policy in Vault to allow it to do that. So my application will be authenticating with Vault using its service account, and we'll get a Vault token back, and the agents that we've injected will get the secrets for us, and our app can consume it. So like I said, we have a Vault server running here. This has already been bootstrapped, and I can quickly show off everything that has happened behind the scenes. This is the agent injector controller. So the thing that's responding to our annotations and injecting Vault containers, it's all handled by this pod. And then the Waypoint server. So the Waypoint server is what's connecting or deploying our applications for us, and then connecting it, giving us a deployment URL at the end, basically orchestrating all of this workflow. So this has already been set up, and I'll just quickly show off what I've done with Vault. So I've logged in, I've unsealed it, I've logged in, I've created a policy, and the policy is basically allows me to use get a database credentials that my app is going to need, and then use the transit encrypt and decrypt functionalities. And so I create the policy. Then I've enabled the Kubernetes auth method. So that would I have told Vault where Kubernetes lives, the service account that Vault is going to be using to talk to Kubernetes, and verify Kubernetes service accounts against the Kubernetes API, and then the CA that Vault is going to be using to verify Kubernetes server certificate. Then I set up a role in the Kubernetes auth method for my app. So this is the app, the role that my app is going to be using once it's logged into Vault, and then I'm going to attach a policy to that role. So the service account app in the Kubernetes, the Kubernetes service account that my application is going to be used is going to be called app. It can be found in the app namespace, and it's going to be using the app policy, which we defined above.
Hey, Jason.
Sure.
Out of curiosity, when you how do you, at least in your experience, what's the best way to decide the time to live for that role, right? Because up there is set to about 20 minutes, but is that arbitrary? Is there a good rule of thumb that you usually stick to when you try to set these time to lives?
Yeah, that's a great question. Typically, we suggest having short-lived tokens, and what's cool is the agents that we're injecting will continuously renew this token for you up until this point, though. So at some point, you don't want to keep renewing a token indefinitely, because that secret's basically now long-lived. But we can say here with this token max TTL, you can keep renewing this up till 20 minutes, and then you'll get a new token, and it refreshes it behind the scenes. So it kind of keeps the blast radius. If these secrets get exposed, there's only so much time that they live for. But there's a lot of things that are associated with the token. So you have leases attached to your tokens. So there's some considerations that you have to make about the types of secrets that you're consuming, and how much the leases that are going to be attached to that token, and how often can my application respond to like a secret that changes a lot. So there's application designs that you need to consider. So long story short, it depends, but we suggest short-lived if you can make the appropriate changes to your application to kind of to work around that design. It's just a much better to keep your secrets short-lived.
Nice. We also had a request in chat to increase it just a little bit more.
All right.
Thank you very much. Yeah, I was actually curious about this because I've been working on a .NET Core application and an example to run it on Kubernetes with Vault. And some, in that case, an ASP.NET Core application, I could do a live reload, right? So I was using Vault Agent to template out app settings.json, and then you can set something in .NET Core to basically reload once the file changes. And that meant that I could always be refreshing that token. So that was really neat. I liked seeing that, but then I was like, wait, but what happens if you have applications that cannot do a live reload like that? So it's good to know some of the approaches to setting a time to live and kind of like the right sweet spot for it.
Yeah, and I'll actually show, so console template and Vault agent templating both support the ability to run commands after the secret has changed. So just getting a little bit ahead here, but the annotations that we're going to be using to configure all this, do I have it here? It's not this app, unfortunately. I don't have it on this app, but basically you can tell the agent template after the secret has been changed to run a command. And one of those commands could be if you're sharing the same process namespace, which is a setting in Kubernetes pod, where basically your applications, your containers, they can see each other's processes and send signals to each other. You can tell the Vault agent templating, after the secret is changed, send a signal to my application process. And if your application can process those signals, like a reload signal, that can be used as a mechanism to say, hey, this file has changed. I need to reload it. So I think this application does support it. I just don't have the command in here.
That's cool though. It's good to know.
Yeah.
I'm going to try it for the next office hours. If anybody's interested in seeing more of that, drop us a note in chat, and we'll try to figure out, who can help us demonstrate that for the next office hours.
So yeah, the next thing I'm going to do is set up the database backend. So I need Postgres database connection or credentials. So we're going to be generating Postgres dynamic credentials on the fly, and our app will be using those. So this just sets up the Postgres database backend. It tells it how to connect, and then we set up this DB app role, which our application is going to be using. So it uses this template to kind of create a specific role for our application to use. So we're going to be giving it connect privileges on a specific database to a specific schema within that database, tables, and then give it permission to select, insert, and update a specific table in that specific schema. And then finally, we're going to be doing the transit stuff for encryption and decryption. So I enabled the transit engine, and then the transit encryption and decryption uses a key. So I needed to populate, tell Vault, hey, make me an encryption key at this location, transit keys app. And this is what will be used for encrypting and decrypting any data that we send to the transit secret engine. Yeah, so that was basically the setup. Like I said, Waypoint's running, Vault Agent Injector, Vault's running, and Postgres is already running. So in this examples folder, there's a Go application, and this is the source code. And this is what I really like about Waypoint. I used to work on Cloud Foundry, and this reminds me a lot of Cloud Foundry, where you have your source code for your application, and then you have this like deployment file that tells you how to build it and release it and deploy it. So it kind of keeps all this stuff together in one repository. And what's nice here is, so this is like the Waypoint file. This is what Waypoint's going to be using to build, deploy, and release our app. We're going to be using our local Docker engine running on my laptop here to build this image. It's then going to push that image into the GCR registry that my GKE cluster is using. And then for the deployment stage, we're going to be deploying into Kubernetes. I'm setting a few environment variables. So this is the app, the path on the file system where my application can find the secrets that we're going to be populating there. And then these are the annotations that we're going to be using to configure the Vault Agent Injector to configure Vault Agent containers for us so that we get the secrets that we want. So like I said, we need Postgres database credentials. So we're going to be getting database creds. DB app is which we created in Vault earlier. I'm going to be using a custom template. So my app doesn't really want to process this secret. So here I'm just creating a Postgres connection URL, and it's going to automatically fill in these blanks for me with the right credentials. The role that I'm going to be, when I log into Vault, this is the role that I'm going to be assuming. So that's app, and then Vault is TLS protected. So we're telling the Vault agent injector to configure my pod to mount up Kubernetes secret that's already out there in my namespace. And then in there, there'll be a CA certificate that I can use to verify Vault's server certificate. And then finally, the service account. This is the service account that I want my application deployed by Waypoint to use. So Waypoint will configure the deployment that it uses to deploy the app. This will be filled in there, and I can show that off once I deploy it here.
So what's interesting to me about this is that Waypoint, we recently Docker Hub, created some quotas, right, or some rate limiting to pulling it. So from a general patterns perspective, if you're doing some kind of lightweight testing, you would previously you would just push it to Docker Hub and then deploy something to Kubernetes. You'd see crash loop back off 100 times. And now that's not exactly the same kind of approach you can take. What I really like about Waypoint is that you could deploy it very easily to the repository of your choice, right? All of that is available to you, and you can use anything that is part of that cloud provider's authentication, right? So Google makes it very simple to set up a repository and allow any of their Kubernetes clusters to retrieve that. So for me, it's I don't have to sit here, find credentials from another image repository, plug them in, write new scripts to point to a new one. I just say Waypoint, direct it to this repository, and then my Kubernetes cluster in whatever cloud provider I want can pretty much just retrieve it. So that's side note. That was pretty neat for me when I tried this.
Yeah, and it's to get an automated pipeline like that to pull your image from Docker Hub. So push your image to Docker Hub, pull it, or automatically to redeploy your application every time it sees a new image. That's a lot of infrastructure and things that you need to set up. But here, all I did was install the Waypoint server, which is super easy in Kubernetes, and then run Waypoint init, assuming I have a Waypoint HCL file. And it just works, which is really cool. And it really makes that developer workflow so much better. So the next thing I need to do is just tell Waypoint, hey, this is a Waypoint project, so just configure everything. So I'm going to run Waypoint init. That's just going to validate the HCL file I've given it, make sure that everything is ready to go. And then you can either do a Waypoint build, which just runs the build step, or you can do a Waypoint up, which does the build and the deployment stage. So I'm just going to do Waypoint up, which is a throwback to the Vagrant days for any Vagrant users back out there. So you see we're currently in the building phase. This is building the Docker image on my local machine. So it uses my local Docker to build it, and then it takes that and pushes it to GCR. You can see here, it pushed to the GCR repository. It's available, and now we're in the deployment stage. So it connected to Kubernetes, to the Waypoint server in Kubernetes. The Waypoint server is now creating the application pod with my source code here. And then because we had annotations, the agent injector saw those existed and automatically reconfigured that pod with Vault agent containers. So you can see down here, we have a demo app running, and it has two containers. So one is our application container, and the other is the Vault agent container. And then finally, this is going to be releasing the application. So it's going to be setting up an ingress or load balancer to point to this application, and we'll be assigning it a URL so that we can navigate to this application.
Thanks.
And it'll just take a moment. GKE's load balancers take a minute. Cool. So we got distinctly crucial deer. Nice. So if I go to this URL now, let's see, I might have went too fast. There it is. So
Nice.
it takes a second for Waypoint to connect the dots, but this is my application. Just to be transparent, I can refresh this. We'll see. Why is it? Hold on.
Let's see. So distinctly crucial dear is actually part, it's a URL issued by the Waypoint URL service. So this is something that is, while you have the load balancer in your in Google, in GCP, in your project, that load balancer then get references, or the DNS references that load balancer, and the DNS service that we're using here is managed by Waypoint. Now you can write your own if you want, but sometimes it's just easier for testing if you want to take a look at your own, just use the deployment URL that's here.
Yeah, so I'm not actually sure why Waypoint isn't connecting the dots. It did for a second, and now this deployment URL is not working correctly. I might have hit, so I've been testing this quite a bit, and I know we have limits on our public deployment server. So maybe that's a part of the issue there. But if I go to the actual service deployment IP address, I can see my app here. And if I refresh this, you can see down here, these encryption values are changing, because Vault has connected to a Postgres database, read some data, encrypted it using transit, and then decrypted it just to kind of show off functionality. And we can see here that these are just like a username and passwords that I read out of Postgres. I encrypted them, and then I just decrypted them. And these are just generated things that I made when these aren't actually users. So yeah, really cool. I'm just gonna try this one more time. Maybe Waypoint. Waypoint's just having a morning, I guess. But yeah, it's really cool though that we can with just a little bit of extra metadata here, annotations, we can consume Vault secrets, and we just ran 2 commands. Assuming this is all set up, we ran 2 commands and our application's deployed is viewable, and then we're using Vault secrets, so that's really cool.
Nice. By the way, for those who are tuning in, have not seen Waypoint yet, Waypoint is in beta. So there are things that you may see that may or may not be working perfectly. We're still, of course, we're still testing and making sure that the stability is there. But actually, so there's what you've showed us, right, is that there's the deployment URL. There's also a release URL. Both of them are publicly available. So if you decide to, I know this is a demo app, but if for some reason or other you decide to print out your database passwords, and at this public URL, is there a way in Waypoint that you can tell it to not have that public URL?
Yeah, so in the release stage of the HCL file, that's where you define, like, I want a service account or a load balancer. So there are configurations there that you can change to basically change how it's actually released. And the release stage is, the either exposing it externally or keeping it private.
Nice. Very cool. If anybody has questions about Waypoint, about Kubernetes, about Vault, please do post in there, post in the chat. Jason showed the transit secrets engine. We have a link to the transit secrets engine in the chat as well. Actually, Jason, could you give a short summary of what transit secrets engine does for those who are less familiar with Vault?
Yeah, sure. So transit secret engine is an encryption as a service. So it allows you to use cryptographic modules to encrypt and decrypt data. So without having your application need to worry about encrypting and decrypting data, which can be hard to implement or vulnerable to bugs, we provide it as a service. So you send us the data, we'll encrypt it and decrypt it using a key that's stored in Vault. So it makes encryption a lot more accessible in that regard. And if you weren't here earlier, the transit engine can also be used to unseal Vault. So it can be used as a KMS provider. So if you're not running in a cloud platform and you need a KMS provider, Vault, transit secret engine, can be used for that.
Nice. Awesome.
I just want to latch onto that a little bit. So I think the important thing that I just want to sort of stress when it comes to the transit secrets engine is Vault will not store your encrypted data for you. It's literally there to encrypt the data, and then you would then store it in some kind of data store, so a database or wherever it is. So it's all about encryption whilst in transit, hence the name of the secrets engine. So that's kind of just something that is a misconception from a lot of people I've spoken to in the past. So I wanted to clear that up.
Awesome. We have a question in the chat. It seems like most people prefer running Vault on Kubernetes using Helm over running it on a cloud provider native service such as AWS EC2 or Azure VM. Any ideas on this? Which do you think is better? This is a contentious topic.
Can I take a stab at this one?
Sure, Rob, go ahead.
All right. Okay. Thank you to the person that asked that question. It's a very popular question. I don't really think you can say one is better than the other. I think what you need to understand is the benefits and drawbacks of each hosting option. So, if you are running on bare metal, for example, then you're going to have a single tenanted vault, which is probably the smallest attack surface you could have. But then when you move to something like a VM, then the tenancy increases a little bit. And then when you abstract to the container layer, it's the same kind of thing, right? You've now got a bit of a bigger attack surface. But what you get with things like using Docker and Kubernetes is ease of deployment, ease of management. So, it's kind of weighing up what's most important to you. Now, the bigger attack surface on the containerized deployments, it's fine. There are plenty of people out there that are doing that quite securely. It's just something that I would just say, as long as you're aware of it, then you're making an informed decision. But I would never sort of say that one is better than the other. That's kind of my take on it.
Yeah, totally agree with Rob. In my opinion, it really depends on your security posture and also how much infrastructure are you willing to run specifically just for Vault. So the Vault, the vulnerability of Vault is its memory. If its memory is exposed, so the host where it's running, then the secrets in that memory can be exported or discovered. So in a Docker world, when you schedule a container to a Docker host, you don't know what is running on that host specifically. It could be a rogue app. It could be an application or a container that has an escape vulnerability and is able to get host access. The actual host where Docker is running could be exposed. So if any of that happens, then your Vault server could be exposed to attack. So in a Kubernetes world, there are things like node selectors or metadata that you can attach to your host to allow you to reconfigure where the containers are deployed. And for Vault, we recommend, if you're running it in Kubernetes, that you have dedicated nodes in your Kubernetes cluster where only Vault is allowed to run. That way, you have these dedicated nodes specifically for Vault. Nothing else can be scheduled there, and it makes things a little bit more secure. And we have a production-ready checklist and a deployment guide in our Learn website that goes through some of these best practices when it comes to deploying Vault on Kubernetes. But yeah, it definitely depends. See right there, maybe you have a 5-node Vault cluster, then you need 5 nodes dedicated just to Vault on Kubernetes. So does it make sense just to run EC2 instances in that case? It really depends on how you want to do your, top down, how your administrators want to administrate all of your services that your applications need, and Vault is one of those.
Yeah, I think from my experience, Kubernetes makes it so easy to run a Vault server, right? Whether or not it's secure is a whole other story, but the Helm chart makes it so easy. It used to not be that easy to, you had to consider a lot of things, how you would run it, where it was going, but the Vault Helm chart makes it so much easier that, no wonder people use it to deploy it. which actually is a nice segue to our next little short demo that I wanted to show, which is the HCP Vault on AWS. So for those who haven't heard, there is a private beta for a managed Vault as a service, right? So basically, we give you Vault servers, and then you can use it to store your secrets. It is in private beta, so there are still some things that work out. So what you see here, what I'll show you is not going to be fully representative of the GA product necessarily, but hopefully it will give you a sense of why you would try to run Vault servers separately on a separate deployment, and then you would just have the injectors in your Kubernetes cluster. So in the case, let me know if anybody in the chat can't see my screen, but also if I need to be bigger on the screen as well. I'll try to make it as large as possible without it falling off the screen. But this is the interface for HCP, HashiCorp Cloud Platform. And HashiCorp Cloud Platform offers Console and Vault on AWS right now. Additional cloud offerings pending, but right now it's just for AWS. The reason why it's over AWS, on AWS, and why it's specific to where it's hosted is that depending on your security posture, most people don't want to run Vault over a public network. Most people want it private. Although either Rob or Jason, please correct me if I'm wrong, but a number of people that I've talked to don't really want to run Vault over a public network, really.
Don't do that.
So we've confirmed, don't run it over a public network. So what HCP will let you do is basically create a Vault cluster in AWS. The Vault cluster is the Vault server, like a server cluster specifically, and these Vault servers run on EC2. So as our question asker pointed out, it will run on EC2 instances. That makes it isolated and for the most part single tenant. So what you actually will get is a Vault cluster here. You can basically say Vault priv create cluster. I have 2 Vault clusters. I'll hit another one if I create another one. But right now, this is my Vault cluster. There's a private URL, there's a public URL. Now, caveat to this, the public URL is there for debugging. Again, this is the private beta. Eventually, this public URL access will go away. It's not going to stay here. But what this will allow you to do is access Vault either over API or CLI. You can also generate an admin token. The admin token is actually set to a lifetime of, I think, 6 hours, something like that. It doesn't exist permanently. So once you generate the token, it's very temporary. It works out. And when you actually set up your Vault server and you connect to your Vault server, you'll want to use the private URL. So what I've done is I've created this Vault server. HashiCorp is hosting this Vault server for me. And how I actually connect my Kubernetes cluster in my AWS account is through a peering connection. So what I do is I peer the VPC that has my Vault cluster and the VPC that my Kubernetes cluster is sitting in. So I peer the 2. As you can see, I've already peered the 2. And both of them, its peering status is active. So what this will do is allow the 2 VPCs to communicate to each other. It's not over the public network, right? So anything that is being transmitted, secrets, etc., to and from Vault, even Vault communicating with the agents, it's not going to be over the public network. So what I've also done is pre-staged a number of configurations because there's just too many configurations. Similar to what Jason, you showed, this is actually using the Vault Helm chart, but the big difference is that it is actually not specifying anything to do with the Vault servers. Thanks to Jason, there is this lovely address, this lovely Helm value that is external Vault address. And what this will allow me to do is say, hey, my Vault servers are sitting on EC2 instances, or they're sitting somewhere else. Here's the external Vault address that I need you to communicate with. So this external Vault address points to my private URL for my Vault instance in HCP. And I just enable true. The agent image, I need to update this, but that's okay. So when you actually get down to the pods that are running, after you've deployed the Helm chart, you'll actually see a Vault agent injector. So this is what is looking for the annotations. It's what's actually going to check for whether or not some Vault sidecar needs to be injected to any application. And similar to Jason, your demo application, I have a Postgres database. And what I've done is I've configured the Vault server to look at, let's see if I remember this. Nope, that's not it. That's fine. So what I've configured Vault to do is basically look at this Postgres database. Actually, the Postgres database is deployed by host IP. So this is actually one of my nodes, my EKS nodes, for example. And so this is not publicly accessible, but it is accessible by the Vault cluster, right, in HCP because of that peering connection. So what's really neat is that I can still grab the database credentials. I can still configure the Vault server to read and create credentials in the Postgres database that's sitting in Kubernetes on a private network. And I can still communicate and create credentials and retrieve those credentials. So that's what you're seeing here. This is a very short demo, by the way. If you're curious to learn more and you would like to try to run this yourself, there's actually a repository that will paste the link in chat. And you can go ahead and take a look and redeploy it yourself. But effectively, with maybe 1 or 2 changes to the Vault Helm chart, you can pretty much do the same functionality that you would do with your Vault, with your Vault on Kubernetes, just having the servers somewhere else and also managed by HashiCorp or someone else. So it reduces a little bit of the responsibility that you might have for either backing up Vault in some kind of state, figuring out what's happening with debugging Vault servers. For the most part, you just pretty much consume the secrets from the Vault server. Granted, there are some additional things we're always looking to improve. So if you have any questions about HCP Vault or any feedback, give us a shout. There's a private beta going on, so you can go ahead and ask questions about the private beta as well. So that's a very quick demo, but anything that I should mention or I forgot to mention, Jason or Rob?
So that external Vault adder setting just got a cool functionality boost in the latest version of the Helm release, where it automatically generates the Vault service account with the appropriate RBAC for Vault to do token review. So you can just enable those settings and then get the Kubernetes secret for the Vault token, and then give that to Vault to connect to Kubernetes and do a token review. So that setup got even easier recently, which is really cool. I think that was a community PR. So big shout out to the community. Thanks for adding that.
Nice. I didn't know that. I haven't tested this one in a while, so now I have to go back and add that in.
It's even better.
It's even better. So something that's not in here that Jason, you showed, which was that you should communicate. Some of the annotations you had in Waypoint that got transferred to Kubernetes indicated that you should be communicating with certificates, right? So something that is not fully here yet, it will eventually be there, but what's not represented as part of this particular example code is the retrieval of those certificates from the Vault server in HCP to load into Kubernetes and thus, allow the agent and the injection, et cetera. Is that necessary? I mean, is that best practice if you run an external Vault server that you should retrieve those certificates and somehow allow the Vault agent injector to have them in place?
Rob, do you want to take this one? Or should I?
I think this is more your bag.
Okay, yeah, absolutely. I would always verify server certificates. I think it's always really good to know who you're talking to and are they who they say they are. Man-in-the-middle attacks can cause issues and expose your secrets. So having that extra layer of authenticity is really helpful. And 2, it's not much more configuration to configure Vault to make your clients also prove who they are. So MTLS using client certificates, Vault can also verify your application or the Vault agents that are talking to it, so that everybody knows that I have certificates that are signed by this specific CA. They're valid. If I add them to like the server, the CRL, the revoke list. Those certs are no longer valid, and I can effectively stop clients from talking to me just through using the CRL. So yeah, leveraging TLS is and everything it has is always recommended for sure.
I'm curious if anybody in the community or anybody has thought to attempt to put a service mesh in front of the like the Vault clients, right? So rather than say here Vault clients, here's the certificate, use this, put Envoy proxy in front of it and terminate the connection at the proxy itself. Has anybody ever brought that up or I guess it adds extra complexity, but is that even a possibility?
So at my last client before I joined HashiCorp, it was a conversation that kind of started, and then obviously HashiCorp snapped me up, so I didn't really get to finish that conversation. But I think that the use case was a little bit different. So you have DNS entries that point to the active Vault leader. And anytime where, if you're sort of in an enterprise environment where you're doing some kind of disaster recovery kind of switchover, you need to make some DNS changes to point to the new Vault leader, which is now your DR cluster has now been promoted to the primary. And that makes the whole process painful for this particular client. So there was talk of potentially using console as kind of doing that kind of load balancing, and it can obviously update the DNS for you without having to go through that kind of pain. Now, in theory, it sounds like a really good idea. Needs investigation, and unfortunately, I didn't get the time to start that. But yeah, it's interesting.
We've also seen it too in the Vault community with Istio, similar idea. Yeah, and we had to add a few annotations to the agent injector to work better with Istio. But I know a lot of people, especially now, more Kubernetes clusters are just coming with Istio enabled by default. So that's, the service mesh is becoming a lot more integrated in defaults, which is cool to see.
Nice. So we have about 10 minutes left. I want to ask anybody who's listening in any questions you have about Vault, Kubernetes, or otherwise. We had a smattering of Waypoint, a smattering of HCP in here. Please post in the chat since we have 10 minutes. But Jason, I wanted to ask, what's next for either Waypoint plus Vault integration, Vault plus Kubernetes? I know we talked about 1.6 specifically, but is there anything that's upcoming that you're excited about?
Yeah, just to be clear, I'm a Vault engineer, so I can't speak too much for the Waypoint team, but I do know that OpenShift support is coming to Waypoint, so that's going to be really cool. OpenShift has a little bit of differences than regular vanilla Kubernetes clusters, so there's some little additional things that need to be done in Waypoint to account for that. But I've tested it; it works really well, and it automatically discovers if it's running on Kubernetes or OpenShift, and configures the server accordingly. So there's really nothing extra you need to do to get it to run Waypoint. It's smart about that workflow, which is really cool. And it just kind of works, which is always nice. And then in terms of like Waypoint and Vault integrations, I know Waypoint is looking more deeply into secret workflows. So direct integrations with Vault and other HashiCorp products are either underway, are currently being developed, or on the near horizon, which is going to be awesome.
Nice. Rob, is there anything you're excited about, either Vault, otherwise?
I think I'm kind of going to echo something that Jason said. So for me, just being able to see, security is all about providing a good developer experience. If you don't do that, you're not really going to succeed when you deploy any kind of security product. So when you look at our existing fleet of products, you look at something like Nomad, for example, and its first-class integration with Vault. You look at how Vault and console work so nicely together. It's fundamental to providing that developer experience. So when we look at something like Waypoint, I'm really excited to see that same kind of first-class integration between Vault and Waypoint there, just to make the workflow nice for the developer, but we're going to keep it secure, to use the words of Jeff Mitchell. So I'm just really excited to see how that's going to play out, what that's going to look like, what the experience is going to feel like, and just ultimately what the community thinks about it.
Yeah, I'm actually excited because so most of the time when I had been working, trying to secure infrastructure, right, there's always been this complaint like, oh, there's friction involved. And as Rob, you pointed out, balancing developer experience with security has always been a very difficult, it was very difficult in general. Different parts of the organization, disagreed. When you were trying to get buy-in on deploying something new, you had to understand and teach a whole new security model, right? And understand what's happening. Kubernetes in particular, trying to explain all of the different ways that someone could compromise a cluster, it's very difficult to learn, and it's very difficult to pick it up very quickly. So I actually am really excited about the newer tools like Waypoint and Boundary and how they actually make this balance a little easier. One of the things that I was playing around with was using Boundary to secure who was SSHing into Kubernetes nodes, for example. So if you're an operator and you need to debug Kubernetes nodes, which is very common, and you reach a break glass situation where you have to go into the node, look at what's happening, you can use Boundary to basically secure who's going into it, right, without necessarily needing to distribute the keys, SSH keys everywhere. And so it's been actually very exciting because, as I said before, when I ran Vault on Kubernetes, I had to do it all myself. There was no Helm. There was just me, YAML, and some stateful sets, and a lot of logic and automation on handling console and then the associated PVCs. So I think as we make it easier, it starts to become secure by default. And that's the idea behind the zero trust model and all of these new tools that are coming out. So I'm pretty excited for it. And HCP has made it even easier for me so that I don't have to sit here and look for a set of Vault servers and back them all up. So that's also been pretty exciting for me to look at.
I think that's a key integration that I'm actually looking forward to, is the ability for Boundary to make use of Vault. So when you need to, in that sort of break glass scenario that you described, you need access to a node, you would never need to know what the password is to get in. Vault will just inject it into the session. As long as you're authorized for that session, you'll be able to go in and do what you're doing, which is, it will make a lot of people, especially security engineers, their lives a lot easier, because we're talking in a lot of these cases with break glass scenarios, highly privileged accounts. So they have access to a lot of things, and you want to be careful that people aren't sort of keeping these credentials, even by accident or on purpose. Sometimes the threat is from within, and sometimes it's not even malicious. It's accidental things where credentials are stored somewhere by accident, and we need to protect against that. I always think that in this kind of security landscape, us as humans, we're the weakest link. So that integration there is a key one for me.
Nice. So are either of you looking forward to anything at KubeCon? Will you be able to attend KubeCon?
I know some of my colleagues are attending KubeCon. I unfortunately wasn't able to attend this year, but always really cool to see the latest and greatest in the Kubernetes world, and what can make my life as a Kubernetes service provider better. I've been working on Kubernetes for a long time now, and it only gets better every year, which is awesome. And there's just, I know Kubernetes has a reputation of being complex, but the reality is that it's a toolbox, and the more tools that I have, the more problems I can solve. And I think it's beautiful personally.
Awesome. So if you are tuning in and you're asking, I know there's a number of people who are asking about, is this KubeCon related? Is this happening all week? So KubeCon is happening all week. And this is actually just a separate deep dive specific to any of the HashiCorp tools. But if you would like either, I know there's a couple questions about vouchers, et cetera. If you would like more information on that, we are on the CNCF Slack for KubeCon. And you can find us on the 6-KubeCon-HashiCorp channel. So if you drop into the Slack or check us out at our virtual booth, you can go ahead and take a look at some of the vouchers, but also get more information, ask us questions directly. We have people in those channels. And with that, I believe that we're going to wrap up today. As a reminder, there are more office hours happening this week. We've got the next one, which is with Kubernetes Console and Vault. So all of the above with Console Connect Service Mesh. And so you'll hear about that at what I guess is 6:15 Eastern, although I highly recommend you check the hashicorp.com/community/office-hours page to learn more. We also have a couple more tomorrow, and those are going to be Boundary in Kubernetes, which we actually talked about. We also have Waypoint in Kubernetes tomorrow. And tune in on Thursday for a smattering of Terraform, Nomad, and Kubernetes, and more. Oh, and we have another one Friday. So definitely check it out. Thank you, Jason, for joining us today and showing us all these amazing things that you could do with Waypoint and Vault and Kubernetes. I appreciate you patiently answering all of my questions, because we all had burning questions about how to run Vault on Kubernetes. And Rob, thank you so much for also joining me to host. And I hope that everybody has a great KubeCon, and we will hear from you in the Slack.